Hello, Per.
Hello.
You are working with what?
I'm working with autonomous load balancing in radio networks, in cellular networks. Sorry. Okay. And in modern cellular networks, you have a mixture between large and small nodes. And there's a problem to make the users of the system to make them connect to the smaller nodes, which are there to offload the larger nodes. And you can do that in modern networks by setting a parameter in the network in each node that biases the decision towards the smaller nodes. But what we've done here is to adjust this parameter dynamically based on information that is generated by the network. So the load of the network is actually influencing how this parameter is set. So in this case, we can see, for example, that the here is much higher loaded than the smaller ones. But in a situation where you have many large and small nodes mixed together in an area where there is varying population densities, the situation can become very complex, and you really need a mechanism to adjust this parameter dynamically. And this is what we've done together with Ericsson. And so it's now finished, this work, and Ericsson has patented this work, and we are hoping that they will implement it in the next generation of their hardware. Yeah.
For you as a researcher, this project, why do you like to work with it?
Because the mechanism involved here is what we call a distributed mechanism. All the decisions are made locally, which means that it can scale to any size network. And the communication between the nodes, which is required here, it only needs to store information about the state of its nearest neighbors, and the rest of the network is somehow implicitly encoded in the mechanism to adjust this parameter. So it's a distributed mechanism with local decision that scales to arbitrary size networks, which is a very interesting class of problems, which we will continue to work with in other kinds of parameter adjustment problems. So it's a very general type of problem, and it's a very general type of solution to that class of problems as well. So this is one example, which is quite a nice demo too.
So this solution, it could be useful everywhere.
Yes, it can be used. I mean, this particular problem to balance the load of the network, then it is a very specific problem. It's a very specific parameter that we are adjusting. But there's many other parameters. For example, I'm also working with problem where you have to decide when the mobile unit is on and when it's off, and this can be adjusted on microsecond or millisecond level, and how to adjust the parameters that decides when the mobile is on and when it's off affects the energy consumption of the mobile, and it's all has to be synchronized with the network. And so these parameters that influences this kind of things can also be adjusted in similar ways. So it's basically it's statistics and distributed algorithms, which is the basis of all of this work. And then we have learned quite a bit about radio networks, cooperating with Ericsson, of course. So it's nice. Lots of interesting problems there.
Okay.
Yeah.
Thank you very much.
Okay. Bye-bye.
Bye.